Hello! Today we're going to start section 3.4 and we're going to solve multi-step equations that have variables on both sides. Our goal is to collect variables on one side of an equation in order to solve and get like one value for x or one value for whatever the variable is. Let's look at example 1. In this equation, if you see, it says solve 20 minus 3x equals 2x. If you see on the equal sign, I have a variable term on the left and a variable term on the right. Well, I need to gather those together on one side and solve for x. Well, since there's only one term over here on this side, I can't leave this side blank. Otherwise, it's truly not an equation, since an equation has to have two sides set equal to each other. So therefore, this negative 3x, we're going to move it over here. So we're going to add the inverse, or add the opposite, in order to zero this out. And remember, whatever I do to one side, I must do to the other. Okay, so if you go down here to the original problem, we can see that to get rid of minus or negative 3x, we add 3x. And whatever we do on one side, we must do to the other. Combining like terms over here, this produces 0, leaving 20, and this equals 2x plus 3x is 5x. How do we undo a one step, or how do we undo multiplication? We divide. So if I want x by itself, I'm going to divide each side by 5, and then 4 equals x. And then we're going to check so we can make sure our answer is correct. Now, if I'm going a little too fast for you, make sure you pause the video and rewind so you can take notes. Let's look at some of these examples. In number 1, I have 5q equals negative 7q plus 6. Remember, I need only one q answer. Since 5q is by itself on this side of the equation, I cannot move it over here, leaving nothing. So I need to get rid of the negative 7q and add it to both sides, giving me 1q. So if I add 7q over here, I need to add 7q over here. Okay, now on this side, I have 12 q's, and over here we have 6. Now I want to get q by itself, so I have to undo multiplication with division. And whatever I do on one side, again, I do on the other. So I'm going to divide both sides by 12. Q equals 6 over 12, which is 1/2. Okay, and then we can go back in and check. I'm going to plug in or substitute in the 1/2 for Q on both sides of the equation and see if it makes sense. Well, half of 5 is 2.5, and half of 7 is 3.5, but that's negative. And negative 3.5 plus 6. Think if you have $6 and you take away $3.50, you would have $2.50 left. So this checks. Okay, let's look at number 2. Same type of problem. I have a variable term over here and my second variable term on the other side of the equal sign. So I'm going to move this positive 14d by subtracting 14d on both sides. Equal signs down. Now notice I only got rid of the 14d's. So what's left? Negative 6. What are 17d's minus 14d's? 3d's. D is multiplied by 3. So to undo multiplication, I would divide by the same thing on both sides. Negative 6 divided by 3 is negative 2, and that equals D. Then I'm going to go ahead and check. 14 times negative 2 minus 6. We want to see if that's equal to 17 times negative 2. This is negative 28 minus 6. That does equal negative 34. It checks. Negative 2 equals D is my answer. I forgot to circle this one. Okay, let's do number 3. I'm going to add y to both sides. 7 equals, I've got negative 8y and negative y. So if I've got a negative and a negative, that should give me negative 9y. And then I'm going to divide by negative 9 on both sides. Now bring down the equal sign. Anything over itself is 1y. And this is positive divided by negative, negative 7/9. And then you would go ahead and go in and check. I'm going to go ahead and skip the check right now for time purposes. We have 3 more down here. If you look at number 4, I have a lot of things on both sides of the equations. But remember, I need to gather up everything that I can and gather one x, or the x term, one of those on either side. Okay, let's look at the left side first. Here I have like terms. This is 1x and negative 2x. So altogether I have negative 1x and plus 3 on the left side of the equals. The right side has 3 minus x. Well, now that I have 2 terms on both sides of the equal sign, this really doesn't matter if I move this term over here or if I move this term over here, because I would have something else and it's not going to be empty. I'm going to go ahead and add 1x over here, which means I'd have to add an x over here as well. So I'm going to bring down my equal sign. These are additive inverses giving me 0, and I have positive 3. On this side I have 3 and a negative 1x, and I'm adding an x. Well, now these are additive inverses giving me 0, and I have 3. Well, now look at that. 3 equals 3, and I know that's true. When you have a situation like this, you have what's called identity. That means no matter what I would put in for x in the original equation, my sides are always going to be balanced. I could put in a whole number, a decimal, a fraction, an integer. Whatever I put in there, I'm always going to get a true statement. That means all real solutions. All real numbers would be solutions for x. Okay, let's look at number 5. If I notice on the right side, order of operations, there's some parentheses here. But I cannot combine those because they're not like terms. So I'm going to have to use distributive property, because now the parentheses indicate multiplication. Okay, now on the left side, I'm just going to bring all this stuff down because I need to work the right side. So I've got 5 times x and 5 times negative 5, which is negative 25. If you're still having to write this out and show the distribution, go right ahead. But when you start feeling comfortable, you can go ahead and skip this step and go down to the evaluated distribution if you're successfully doing it. Okay, let's gather our variable terms on one side. I'm going to go ahead and do minus 5x on this side. If I do that on one side, I must do the same on the other. Bring down my equal sign. On this side altogether, I have a positive 24. Over here, these are additive inverses, and I end up with negative 25. Well, that's not true. 24 is not equal to negative 25. So when I have a not equal statement, that means no matter what I plug in for x, I'm never going to get something true. If I put a whole number, an integer, a fraction, a decimal, no matter what that number is I put in for x, I'll never get an equal statement. That means I have no solutions. Nothing will work. This is not true. No solutions. Okay, one more problem. If we look at this problem, we have a lot of things that's going on here. So let's do one thing at a time. Let's look at the left side. Bring down the equal sign. Order of operations says parentheses first. I cannot subtract these. They're not like terms. So that must be multiplication. So I have to have distributive property. but there's no number here. So what was that number that we know of that's going to be here that's distributed? Well, that's right. If it's a -1, if that's what you said, you're right. So the 6y I'm going to bring down. I'm going to do -1 times 3y. And then -1 times, that's a -7. Should have put my equal sign a little bit over that way, sorry. Okay, so I have on this side 6y, -3y, +7. Okay, let's look at this side over here. I have a fraction that I'm going to distribute. So when I multiply with fractions, I can cross simplify. So this 5 is going to simplify to 1, and the 15 is going to be a 3. So what I really have here is 2/5 times 15y and +2/5 times -20/1. Okay, so 15 divided by is 3, so 2 times 3y gives me 6y. We can cross simplify here, that gives me -4, and +2 times -4 is -8. Okay, now on this left side, 6y minus 3y is 3y. Bring down the +7. 6y minus 8. Let's gather like terms over to one side. I'm going to move this +3y over here, so that's going to be a -3y. Then on this side of the equal sign, I have a +7. 6y minus 3y is 3y minus 8. And now I have a two-step. Add 8 to both sides. 15 equals 3y. Divide by 3 on both sides. And then I get 5 equals y. Now I'm going to circle it. Whew, that's a lot of steps. So I've really got to be careful what I'm doing. Because if I make a tiny mistake up in the beginning, everything else might not be so simple. So what I would like for you to try now is on page 157 in your resource book or your textbook. It is section 3.4, number 12 through 14 all, and 18 through 26 all. You will be practicing various types, at least one of each kind that we just showed here today. And if you have questions, please ask.